about square root functions and inequalities. So take a look at these two graphs. What information can you gather from the graphs? Okay, so we already discovered that this right here is the parent graph of y equals x squared, right? So we know that the square root of x is the inverse function of that, right? So it gets actually reflected, correct? We just talked about that. This is the same thing, only what? It's only part of it. Why? Okay, part. So you guys say that that's positive and negative, so that's including both of them. Good, I'm glad you noticed that. But isn't there always a positive or negative in front of the square root sign? I'll give you a clue. Why? Sure it can. I'm glad you guys are thinking in the right direction. You're thinking imaginary, right? That imaginary comes into play, but not why. This is only right here. It can be negative. Here's your clue right here. This is not a function. This is a function.
Oh, because it's... Oh, no, I like that.
Good. I get a bunch of people that are waving their hands up in the air. The vertical line test.
Oh.
So in order, this is a graph of the square root of x. But this is not a function because of the vertical line test. It can't pass through 2 points on a graph, right? This one is just so, this would also work as well. I'm going to erase it as soon as I draw it, though. This would also work if this was away, if that wasn't there, right? That would just be the negative portion of it, right? See what I mean? But you can't have both, one or the other, in order for it to be a function. All right, so let me erase that. That would be a good question. Okay, so still want to talk about behavior, all right? This will help you, believe me, but you don't have to do this. All right, so the square root of x would look like, this is not drawn to scale, something like that, right? What about the square root of x plus 3? Not shifted up. It would be over 3, right? What about this one? Up 3. Right? Because if you set that equal to 0, right, it goes to the left. Okay? Okay, this one would be to the right 3, and then what? Opposite direction. So instead of going like this, it would be, right? Because isn't that the other half of this graph right here with a negative in front of it? Wouldn't that be the other side of it? Right? Okay, you okay still? Everybody all right? Okay, so let's do this one. This one's more difficult. No, not yet. Yeah, you're right. It would be up 3. You're correct on that piece. Okay, but let's put it in the right form. This is not in the right form, right? Okay, negative x plus 3 is almost there, Ryan. This is more accurate. You've got a negative coefficient here, which would make the x positive and the 3 negative. Right? Okay, check this out. So that would be what? What would this shift? This goes to the right 3, and then what would this out here do? Up 3. Now, here's the million-dollar question. What would this negative sign do to it? Arrow point to the left. Good job. Okay. That's just like when you had this. If this is a positive x squared, when you have a negative coefficient, wouldn't that make it go down? So if this is it going positive, wouldn't a negative coefficient make it go that way? Right? You guys okay still? It's hard, huh? It's hard to think about. But wait until we get to the graphing part of it. You having this piece of information right here is going to help you a lot, okay?
Did you say you had a note?
I do.
So will that be on the note?
We're gonna do a little side note, behavior of graphs, okay?
Okay.
All right. So this one's way harder, and this is why you have to graph these. You can't just do behavior of graphs because you get stuff like this. Okay. So what's my coefficient here? 2. But I have to pull out that 2, and what would I be left with?
Oh. 3/2.
3/2. Right? Sharp as a tack, Jesus. 3/2. Okay? Process that for a second, right? If I were to take out 2 from 3, think of it in the reverse. If I multiplied 2 times 3/2, wouldn't that be -3?
Yeah.
Okay, so this graph would be shifted to the right 1.5. It's a positive coefficient, so it's going to go like this, right? But now it's negative, so it would go down and to the right.
Why is it only 1.5?
3/2. 3/2 is 1.5. Okay? Okay, here's another thing. Check this out. Before, when we had a coefficient greater than 1, it made it really skinny, right? That's because it was shooting up. But when we have a graph that's going like this, and that coefficient is 2, it has an effect on, this makes it shoot up, right? Well, what's going to happen if this graph is pulled up? Can you imagine? Shooting up makes this go up faster, right? Rises at a faster rate, it's going to be wider, right? Because that 2 is making it pull up faster. So before, our graphs would be really skinny if it was 4x. Now 4x on the side is going to pull it and make it wider. Okay, now that you're all set, we've got all this background, let me get started. I don't want you guys to write anything down until I go through the whole thing. Okay, then I'm going to give you your notes and you're going to copy it down. And we go through all the entire thing. Okay, so I'm going to graph y equals the square root of -2x plus 3. My first step is to predict the behavior of the graph. So I know that's going to be a fraction, right? Just like I did that last one, it's going to be a fraction. It's not necessary to actually do the fraction, but I'm going to do it anyway. Okay, I know this is going to be the square root of -2 times x minus 3/2. Right? Okay. So that means this graph is going to be shifted over this way, right? Then it's going to be shifted what? Not down. It's not going to go this way. I shifted it over 3/2. This is a negative coefficient. What does a negative coefficient mean in quadratics? It means it's frowning, right? So frowning means it's going to go that way. And I'm going to put all of those up when you guys take your notes. We're going to put the behavior of the graphs. All right, so set the expression under the radical sign greater than or equal to 0. So I'm going to take -2x plus 3. Clarissa, what are you looking down at? Nothing? Okay, you keep looking down. So -2x plus 3 has to be greater than or equal to 0. Let's discuss that. Why does this have to be greater than or equal to 0? Because you don't want a square root less than 0. Why? Then you get imaginary numbers, right? So when I set that greater than or equal to 0, what does x become? -3/2. Let's do that again. I'm going to do this one over here. exactly. Negative 2x plus 3 is greater than or equal to 0. Subtract 3 from both sides, and I get negative 2x is greater than or equal to negative 3. Divide by negative 2. Divide by negative 2. Let's pretend I didn't hear that. X is greater than or equal to positive 3 halves. So I'm going to go to positive 3 halves, right? And I'm going to go, this should have been positive. Negative, no, it's right, positive. And this should go this way? I know. This way, right? Doesn't this say it's supposed to go this way? I didn't flip the sign. Now, wouldn't you say that that's a pretty common error, not flipping the sign? So if I didn't have an idea of what this is supposed to do, I would have started this whole problem wrong. Just based on the fact that I didn't look and predict what it was going to do. So I go back and go, oh yeah, I forgot. I forgot to flip the sign. So, So I know that this graph is going to start right here, and it's going to go this way. All right, so let's get started with that. Or I'm going to get started with that. So the first point I'm going to put in here is 3 halves. Why? Because I already have that, right? I know that's a part of the graph. So negative 3 halves times negative 2. Sorry, 3 halves times negative 2 is negative 3. Plus 3 is 0, which is 0. Right? Now, which way am I going to go? Am I going to go in the positive direction? No, why would I go in the positive direction when I know this graph is going in the negative direction? So what are you going to put in now? You could put in 0. You could put in 1. I wouldn't go so close, though. And you'll see why in a little bit. Okay. You want to go with negative 1. Let's go with negative 1. What do I get when I get negative 1? Positive 2 plus 3 is, what's the square root of 5? Get a calculator out and tell me. Not everybody move at one time. 2.4? I love that you guys are trying to do it without a calculator. 2.2? Does it have to be super accurate? No, it's a graph, right? So negative 1, 2.2. Awesome. Does that look like it's supposed to? Okay, do another point. Negative 4 would make the square root of 12. What's the square root of 12? Between 9 and 16, right? 3.6. What is it? 3.4? So if I put in negative 4, I should get 1, 2, 3 point, somewhere right there. I need one more point. What do you want to do? Negative 6? Negative 6 times negative 2 is positive 12 plus 3 is square root of 15, which should be just under what? 3.8? Should be just under 4, right? Because the square root of 16 would be 4. So negative 6, 1, 2, 3, 4, so right about there. Is that making sense? Talk about domain and range. I love this because until today, domain and range has just basically been, well, she keeps saying all the real numbers. I don't really get it, so I'm just going to put all real numbers. Right? Pretty much? Okay, well, today is the end of that day. All right? Check this out. There's meaning to it now. What x has to be, x such that x, what does x have to be? Less than what? Less than or equal to 3 halves. Right? It doesn't go any further in this direction. What about my range? Y has to be what? Greater than what? Think of the y-axis. 0. Right? there is nothing down here, and there is nothing right here. All of that is eliminated. Make sense? So x has to be less than 3/2, and y has to be greater than 0. Does that help, my little covering up? Okay. I think I'll take those off, though. Let me get you your notes. I want you guys to write all of this down, including, let's do this over here. Let's give ourselves a little, no what? Why no? Yeah, it is blue. It shouldn't be blue. I want the outside to be blue and the inside to be white. All right, so we have the square root of x should look like this. The square root of negative x should look like what? That. Negative square root of x should look like down. And the negative, what should that look like? Right? So make sure that's on your notes too. Okay, so let's try this one together. So y equals the square root of x minus 1 plus 3. So the behavior of this graph is going to be, let's look inside first, is going to be shifted what? To the right or to the left?
To the right.
To the right, and then shifted up 3. And then what's it going to look like? Are there any negatives affecting it? No. Okay? So now that I've predicted, let's set the expression under the radical sign greater than or equal to 0. So x minus 1 greater than or equal to 0 is x must be greater than or equal to 1. Right? So since x has to be greater than 1, what's my domain? X must be greater than 1. You'll see it right now. So where am I going to start then? 1. What happens when I put in 1? 1 minus 1 is 0. What's the square root of 0 minus, plus 3? 3. 1, 1, 2, 3. Isn't that what we predicted up here? 1, 3. Then where would you go? Why 2? Because if you put in 2, you're going to get 2 minus 1 is 1. What's the square root of 1? 1. What's 1 plus 3? 4. So over 2, up 1, 2, 3, 4. What would be the next number you'd put in?
4.
Nope.
5.
5. Why 5? Because 5 minus 1 is the square root of 4. What's the square root of 4? 2 plus 3 is 5. No, the next one we would pick would be 10. Right? Because 10 minus 1 is, I knew what you meant, is 9. The square root of 9 plus 3 is 6. If at any point, why would you do that? Because why? Because why not just put it in a calculator? Somebody raise their hand and tell me why not just put it in a calculator? Raising a hand, right? Okay, let's hear it. Put it in wrong, you're not going to get the right answer. But all of you can see that the square root of 4 is 2 and 2 plus 3 is 5, right? So if you can find values that work, I would put in values that work. If you can't, then put it in a calculator. All right, so 10, 6 would be right here. Is all of this looking like our behavior of our graph? So the last thing we need to do is talk about what our range is. Y such that, what does y have to be greater than or equal to?
3.
Good job, you guys. Right? Y has to be greater than 3, right? Is it ever less than 3? No. Is it ever less than 1? No. right? That's where it's restricted. Can't go this way, can't go down. Make sense? You guys ready? Okay, so pencils down again. You know, we don't need pencils down with this one. What's the difference between this one and the last one? There's an inequality sign. What do inequality signs involve? Shading. So the only difference between this one and the other one is shading. Awesome. Also the dotted or the dashed line. Yes. Evan.
When you say it, how do you know like when to stop?
We're going to do that right now. Okay? Yes.
I'm going to know if our lines are like perfect in the curvy thing because I can't draw a good line.
Yeah.
Are you going to draw lazy lines, or are you just, nobody said it had to be perfect, right? But if I see just like this, you think I'm going to say that that's good? You need to follow the dots. Exactly. Okay, let's get going on this. We know this is going to be a fraction, right? So if we set 3x plus 5, I'm starting with this one because I know it's a fraction and it's going to help me with my behavior. So 3x plus 5 greater than or equal to 0 would give me what? X is greater than or equal to what? Negative 5 over 3. We're going to use this with the behavior because I'm using step 2 to help me with step 1 right now. Because I know that this is a fraction right here. So if I pull out 3, what do you think that's going to be? X plus what? 5/3. Right? Just like I already found over here. See that, Janelle? It helps me with that. All right, so this graph is going to be shifted what? To the left. 6/3 is 2, so 5/3 is a little less than 2.
Yeah.
Right there. And the 3 affecting it. How does the 3 affect this graph? Wider. Right? But it's going to go this way because there is no negative sign. So it's going to do, so we're doing behavior now. So it's going to be over here and it's going to be like this somehow, wide. Okay, so what would I start with?
1, 0.
No. Negative 5 over 3.
Oh.
What do you think I'm going to get if I get negative 5 over 3? 0. Right? There's that. What do you want to put in next? Let's just put 0. Right? Because this is fractions and that's hard. So, let's put in 0. What do you get? Square root of 5, which is 2.2. We just did it. Right? Okay, I wouldn't put in 1 because your numbers, since we're dealing with decimals here, it's going to look funky. Right? So I'd put in like 7. Put in 7. 7 times 3 is 21, plus 5 is 26. What's the square root of 26? 5 point something? 5.1?
5.0.
5.09. Okay, so 5.1. So 7, 1, 2, 3, 4, 5.1. Does that look right? It's right to me. It's almost like Angry Birds. Right? Where's it going to go? Huh. True. Well, think about square root functions now. Okay. All right. We need one more point. What are you going to put in? 10. What do you get when you put in 10? Square root of 35, which is somewhere around 5.9. Right? I know that the square root of 36 is 6, so isn't it going to be just right underneath it? So 10 and 6 is right there, so like right there. There it is. I would make sure that I can see those, though, when you do this. Melanie, that was a 7-minute bell. You know what it is? It's just really low on Wednesdays. You can barely hear it. I think that was a 7, yeah. Okay, what did I forget?
The dash line.
Number 4, dash or solve. So I'm going to do what you guys do on tests. Here we go.
That's exactly what I do.
Because I see it. You know how else I know? Because I used to do it. That you forget about it, and then you go back and you get your eraser and you erase it. Okay, what else do I need to do? Ooh, we haven't done the domain arrange. So what's my domain? X such that negative 5/3, right? And what's my range? Y has to be greater than 0 or equal to 0. Hold on, Boston, I see it. Let's test a point. What point would you like to test, Jesus?
0.
0, 0, that'll work, right? So if y equals 0 and x equals 0, then wouldn't this be, is 0 greater than negative 5? Square root of 5? Why am I even saying negative? Is 0 greater than the square root of negative 5? So is this included? No. So where's the shading going to be? Okay. Is everything above it? Are there values down here anyway? No. No? Yes. Well, yeah, because are there any values down here? No. Yeah, it's going infinity out there. So left? Yeah, just because there's no graph there doesn't mean, right? Oh, I see what you're saying. Yeah, because it's all the y values above it. I see what you're saying, like this. That would make more sense, huh? No, because it's all the values that are greater than. So aren't those greater than values? Yeah. If you think about it, right? Yes, Xavier. Just stretching. Awesome, I'm sorry. I keep skipping over you.
I don't understand what you do when you go to the point and get 0 and then you go to 7.
Because I don't want to know because they're decimals. Awesome. They're decimals. If I put in 0 and then I put in 1, I'm just going to get another number that's like right there. You know what I mean? So I'm just going out there. I'm just saying, you know, I'm going in this direction. So why not just pick 4? Why not just pick 6? I'm just going out there. To pick whatever number you want, as long as it's not in the negative direction right here, right? It's just 4. I want 4 numbers. Okay? Yes. Because this right here. Oh, which one to test? I thought you meant where we start. Everybody understands that we're starting here because it's, why? There we go. We're starting here because that helps us with that. What do I test? I tested 0, 0 because 0, 0 is always the easiest thing to plug in. Right here? Because if y is 0 and x is 0, isn't 0 greater than the square root of 5? I plugged in 0. I plugged in 0, 0. Let's do that. I'm going to plug in test 0, 0. And when I test 0, 0, I get 0 is greater than 3 times 0 plus 5, which makes 0 is greater than 5, which is a no. Therefore, 0, 0 is not included. We'll make that with we'll make it red. No. Does not work. Is that better, Evelyn? Yeah. Okay. All right, let's do the last one. You guys do this one. I'll finish up this. Okay, so let's finish this last one. So I know the behavior of my graph, judging by this, means it's going to come this way and go this way. So let's set the expression of the radical sign greater than or equal to 0. X plus 1 has to be greater than or equal to 0. So x has to be greater than or equal to negative 1. So here's negative 1, just like we said. So if I put in negative 1, I'm going to get the square root of 0, which is 0. So let's try, how about 4? How about 3? If I put in 3, I get the square root of 4, which is just 2. So 3, 2. Another good one would be, what about 8? 8 plus 1 would be 9. Square root of 9 is 3. So 8 and 3. And what if I did 0? If I did 0, it would be the square root of 1, which is just 1. So 0, 1, that makes sense. This is a greater than or equal to, so I know it's solid. And then my domain is x, such that x is greater than or equal to negative 1. My range would be y, such that y is greater than or equal to 0. And my test point would be 0, 0, which would be y is greater than or equal to 0 plus 1 is 1. Square root of 1, is that true? No, so this is not part of our shading. And my shading is going to be above this line. Uh-oh. All done.